So I need you to consider the point A, which starts at -1, 2, and then B, which is another point way over here. Let's call it 3, 4. So imagine those points are sitting in space, and there is a line that is directly between them. All right. Now it says find an equation that expresses the fact that P of xy is equidistant from A and B. So that only happened a long time ago when your teacher in grade either 10 or 11 gave you the concept that you could have a line that perpendicularly bisects the line for AB, and that each of the points that is on this new line has exactly the same distance from it. Okay? So, if we come up with a general point P, xy, for some line like that, we can easily go and calculate calculate the equation of a line for it. So let's go over how we're going to do this. All right, so the first thing that you're going to do is you're going to remember that you have the line that's splitting it between the two, and there's the point xy there, right? What you're going to do is you're going to go and come up with two equations that represent the distance from A to B, from B to P, and then from A to P. And then we'll equate them and then solve for xy. So let's begin. So here is what you know. You know the distance from A to P is given by the square root of x2 minus x1 squared plus y2 minus y1 all squared, right? Here is A. A is the point -2, -1, 2. -1, 2, and P is the point x, y. All right, so let's go. Let's substitute directly in. This is x2, this is x1. So now when we substitute, you're going to get the following. X squared, x minus 1 is x plus 1 squared plus y minus 2 all squared. Now let's go and calculate the distance from B to A. Sorry, B to P. So when we calculate the distance from B to P, it's going to also equal the square root of that same thing, but here is B, which is 3, 4, and this is P, which is x, y. So we just substitute. So we got x minus 3, x minus 3, and then y minus 4. X minus 3 squared plus y minus 4 all squared. So now that I've got that, what we can do is we know that this equation here, 1, is equal to 2. So the distance from A to P, based on what we were studying before, is identical, right? Remember, I said that. It had to be the same. So now we're going to use those two distance equations, and we're going to let them be equal to each other. In letting them be equal to each other, you're going to get the following. So you're going to get the square root of x minus 3 all squared plus y minus 4 all squared is going to equal the square root of x plus 1 squared plus y minus 2 all squared. Now that I have that, if we square both sides, all we end up with is x minus 3 squared plus y minus 4 all squared is equal to x plus 1 squared plus y minus 2 all squared. So now we're going to take our time and we're going to expand this that's in red. So get out a separate piece of paper and expand it. We're going to expand this. We're going to expand this. And we're going to expand this. Okay? Each of those need to be expanded. So when we expand x minus 3 squared, it's going to be x minus 3 times x minus 3. And you expand it, right? Now, I'm not going to show you all of that. You should be able to do that on your own. But I will give you the final result of expanding that. So you're going to get x squared minus 6x plus 9 plus y squared minus 8x plus 16 is equal to, in green, x squared plus 2x plus 1. And this last one in green, and the last one here, we have plus y squared minus 4y plus 4. Okay, so now let's collect all the like terms on the left side and all the all the like terms on the left side. So I got x squared and I got y squared, right? I got minus 6x and I got, oh, there's a y here. I apologize. Change this to a y. I got minus 6x minus 8y. And then I've got 9 plus 16, which is 25, which is equal to, do the same on the other side, x squared plus y squared. Now we'll put our x's and y's together. So I got plus 2x. And then I also have minus 4y. And then I have 1 plus 4 is 5. So now let's move everything onto one side. You'll notice that if I have an x squared on this side, that cancels with this. There's a y squared, that cancels with this y squared. So we're left with, on this side of my equation, negative 6x minus 8y plus 25 plus 25 is equal to on the right side, minus 2x, no, plus 2x, minus 4y, and plus 5. So now let's move all the x's to one side. Sorry, all the y's to one side and all the x's to one side. So I'm going to move all the x's and I'm going to push all of these numbers onto the right side. And you're going to get this. Well, the 2x doesn't change its sign. So you end up with 2x. The minus 6x becomes plus 6x. And then the 5 still stays the same. And then we have minus 20. And then we have minus 8y. Bring the minus 4y to the other side, so now becomes plus 4y. And then we simplify by collecting like terms. So minus 8 plus 4 is negative 4y is equal to positive 8x and then minus 20. So now our final stage, divide everything by negative 4. All right, now that we've got negative 4, you solve y is equal to 2x minus 2x plus 5. And that is your answer to do this problem. So that is the full solution. One of the students in my class said that they could use a perpendicular bisector to find the equidistant line points. That's it, and I helped them do that. That's why we had the one solution the one way. But this is the full solution based on what we learned in this unit.